Okay, in this assignment, we're going to be looking at mechanical advantage, which is a quick and easy way we can look at what a simple machine does for us. In most cases, we like to think of simple machines as things that require less force for us to do the same job, to do the same work. So, if we want to apply a force to move an object some distance, if we could find some way to make it so that we don't have to put in as much force on our part, that would be great. Everyone likes to do less work, okay? But the trick is we end up doing the same amount of work, just requiring less force. Now, there will be a trade off, and we're going to see that here in a bit. But the way that a simple machine does the job for us, either by changing the direction of the force or by how much force we have to put in, or by the distance we have to move the object, comes out in the mechanical advantage. So let's say you've got a crate. You've got a crate that's takes 100 newtons of force to lift straight up off the ground, and you want to lift it in some way that takes less force. So use a simple machine like a really fancy lever or a pulley would be great for this job. You hook it up and let's do with the pulley. You pull on the rope and you lift the crate. And when you lift it with the pulley, it only takes 50 newtons instead of 100. Well, if I want to figure out how much easier or harder that made it on me to use the simple machine, I can calculate the mechanical advantage. So let's get a calculator out here. Okay, so this isn't really a question on the page, but this is to just kind of demonstrate it. So if it would normally take me 100 newtons of force to do the job, we're going to say that is the force out. Okay, that's the output we're trying to get done. Okay, whether we put in all that force or we get the simple machine to do some of it, this is what has to be accomplished. We have to apply 100 newtons of force. Okay, you also might call it the force before or the force without the simple machine, the usual amount of force, however you want to call it. But in our equation, it's this force out part. I'm going to divide it by the force in, the input I have to use with the simple machine. Okay, so if I use my pulley and I lift up the crate, it only takes me 50 newtons of force instead of 100. I can take my usual amount of 100 newtons, divide it by 50 newtons. Oops, should have lifted that up a little bit. Can I backspace? Can I? Okay, there we go. 50 newtons. I get 2. Okay. What that 2 means is the job is now twice as easy as it normally would be, okay? Or it requires half the force, okay? So, whenever you get a mechanical advantage that is greater than 1, that happens because the force that we are plugging in with the simple machine is less than what we're plugging in for how much force it normally takes to do the job. Okay, the force before is going to be greater than the force after. So whatever we plug in here, our answer is going to be bigger than 1. It could be 2, it could be 3, it could be 10, it could be 200, it could be 1.05, but it's going to be greater than 1. Okay, what that tells us is the work is going to be easier than usual. Okay, compared to not using the simple machine, it takes us less force. Okay, this is how we find most simple machines working for us. A lot of them will reduce the amount of force you have to put in with a trade-off that we'll talk about here in a bit. But let's see the other scenarios that could happen. Okay, so let's say you were using a simple machine like a lever. And let's say the lever is set up to lift that same crate. It's going to take 100 newtons of force to lift it normally without the machine, without the lever. And then we try using the lever to lift it up. So I push on the machine, I push on one end of the lever to lift up the other side that has the crate on it, and it takes me 100 newtons still. So my mechanical advantage would be 100 newtons as my force out, that's what I'd normally have to do, divided by the force I put in using the simple machine, which in this case, by using this lever, was just 100. So it normally takes 100 newtons of force to do this job, and now with the lever, it still takes 100 newtons. My mechanical advantage is going to be equal to 1 for this simple machine, for this lever. Okay? If the mechanical advantage is equal to 1, that means the job is no different. The work is not harder, not easier. It's the same as usual. Okay? Which kind of feels like we're defeating the point. But it might make it a little bit easier in the sense that we can change what direction we have to apply that force and things like that. So I'm still going to need to put in 100 newtons using this machine, but maybe instead of having to lift the crate straight up, I can stand on the other side of the lever, kind of like a seesaw. So I can use my own weight to press down on one side to lift the other. My weight can still exert, some newtons of force, um, which I don't think it's going to be 100. Thankfully, I don't think I exert 100 newtons of force, but I could at least put in some of that force just by standing on it instead of having to actively lift the box myself with my bare hands. Okay, so there are reasons why you might have a simple machine that doesn't give you a bigger mechanical advantage than one, but it does still help you in some ways. Okay. Now, the one that always got me was this: using a simple machine that takes more force than normal. So, let's say you are trying to hit a baseball or something like that, or a golf ball. That is also a kind of lever, but where your hands are positioned and where you end up kind of pivoting as that fulcrum is where your club or your hockey stick or your baseball bat is rotating. Um, it ends up taking more force than normal to get the job done. Okay. Since the force before is going to be less than whatever we put in with the simple machine, it seems kind of backwards. Like, why would I use the simple machine if it's going to make it harder on me? If the work is going to be harder, it's going to require more force. There's a trade off, though. Work is taking the force, applying it to a distance. So if it's taking me more force, I might have to do the job in less distance. Okay, when you swing a baseball bat or a hockey stick or a golf club, where your hands are moving, there isn't a whole lot of motion. Okay, if you kind of like measure out the arc that your hands have to twist and compare it to how far the other end goes as it swings, there's a pretty big difference. Okay, you can make a lot of motion on the end of your bat or on your golf club just by doing a little bit of motion on the end where your hands are. Okay, there are also reasons like weightlifting and working out in the gym and stuff like that. Um, if you are doing something like pull-ups and you hook yourself to a device that pulls down on you with a set of pulleys or something like that, it might make it harder for you to do that same job, but it might give you the resistance you need to actually strengthen your muscles. If doing a pull-up is easy enough as it is, you might need to make it harder on yourself. You'll see it especially with like these machines that have like tension and pulleys and things like that. Those are the ones I usually think of when it comes to this. Or you have to pull on two handles to bring them closer to your the middle of your body, or you have to lift them up and do like a bicep curl or something. And those handles are usually made of like foam, and so they're really light and they're easy to move. But as soon as you hook them up to those pulleys, it takes a lot more force on your part, okay? Which means you got to strain your muscles more, you're going to break them down, and you're going to have to rebuild them stronger the next time. So in that case, that would be really helpful, okay? If your workout machine made things really easy on you, you'd never get any stronger. So there is a reason for this. It's just not as common as a simple machine that makes our job easier on us. That's the one we see the most. Okay, so let's look at some examples of how work and mechanical advantage and force all relate to each other. So we've got our equation for work, force times distance. Okay, and we have a case here where we're trying to lift a 20-pound weight up 1.2 meters off the ground. So if this is just me picking up a 20-pound weight and heaving it up straight off the ground, it's going to take 88.98 newtons from me to lift this thing up. Okay, if I want to know the work that I have to do to apply that 88.98 newtons to lift it 1.2 meters, I just have to multiply them. My force in this case is 88.98 newtons. Okay, the distance is 1.2 meters. Let's do that in green. Okay, so if I take 88.98 times 1.2, I should get the work that I have to put in to get the weight that far off the ground using that force. So let's do that. I'm going to take 88.98 times 1.2 meters, and that gets me 106.776. Okay, and work is measured in joules. The same as energy, it's how much you're able to get done with something. In this case, how much we are doing by applying this force for this length of distance. Okay, Now, maybe I don't want to pick up that weight by hand because that is a lot of work to do for me. And like I got delicate hands. I don't want to like break a nail or something like that. Um, so I'm gonna try and find a way around this where I don't have to put in as much force. Okay. So if I'm not looking forward to getting sweaty trying to lift this weight up and down by 1.2 meters, maybe I'll use an inclined plane, which is a simple machine. Okay. Basically a ramp that I can slide the weight up instead of having to pick it straight upwards. So in this case, I let the ramp do some of the job for me. I let it kind of apply some force by pushing back against the weight as it rests on it. So I'm doing more of my pushing sideways than I am lifting straight upwards. Okay, and it's going to be easier for me to push it sideways than it is to go straight up against gravity. Again, the ramp is going to kind of support me in that effort. It's going to kind of push back for me. So let's say I do that. It ends up only taking 44.49 newtons of force to slide that 20-pound weight up the ramp, but the ramp has to be 2.4 meters long. So I end up getting the weight to the same place. It ends up 1.2 meters off the ground, but my ramp has to be like twice that distance, okay, that I'd normally have to lift it just straight upwards. So let's see how much work I'd have to do doing this, okay? So my force is less. It's 44.49 newtons. 44.49 newtons. Okay. Oh, let me highlight it. Let's do this. Make it all fancy. Okay. And I have to slide it 2.4 meters. Ends up in the same place, but since the ramp is at an angle, it doesn't go straight up. So it's going to take longer for me to slide it than it is for me to just pick it straight upwards. So I'm going to take this 44.49 newtons of force and multiply it by the distance, 2.4 meters. And what I get is the same number. I get 106.776 joules of work that I have to do. Okay? And this is really the whole point of a simple machine. We accomplished the same work, but I had to put in a lot less force. This is like half the force, okay, compared to this guy. Okay, it took me twice the distance because now I'm sliding it instead of picking it straight up. So I've got to take a kind of a longer path, and it's probably going to take me longer in time wise, like how many seconds or minutes it takes me to slide or lift it. Hopefully, it doesn't take me minutes. Oh man. But at least I can do it with a lot less force exerting on myself. I don't have to get so sweaty, I guess. Okay, so when you use a simple machine, you can change the amount of force, you can change the amount of distance, and you can change the direction you do the force in. Like I had it with half the force going twice the distance, now going more sideways than upwards. Okay, but in either case, the work is the same. I don't end up changing how much work I accomplish. I only change force, distance, and direction. Now, not all of these have to change all at once. Sometimes you'll have a simple machine that still applies your force in the same direction, but it decreases the force. Or sometimes you will have a simple machine that does increase the force, and therefore it decreases the distance, but the direction is still the same. Okay, so it just kind of depends on the situation. Let's go on to the next page. Oh, wait, no, there's more down here. Ha ha. Okay. Okay, so I guess I kind of answered some of this preemptively. In other words, doing a task in a shorter distance would require more force if the work done is the same. Okay. If I want to accomplish this work by doing less distance, it's going to take more force for me to do the same amount of work. Okay. It's got to come somewhere. I got to put the effort in somewhere. Okay. If I'm going to do more work on my part, I can do it in a shorter distance, or more force, I should say. If I do less force on my part, then I can do it, but I end up increasing the distance I have to apply that force. Okay, so I can either have more force with less distance or less force with more distance. It's kind of like a scale. It kind of flips either way. It kind of one side goes up and the other side goes down. Okay. Now, if we want to know how well this works, like this incline, this ramp works, we can calculate the mechanical advantage. So if I have something like the force normally taking 88.98 newtons to lift the weight straight up, and then I use this simple machine that takes 44.49 newtons instead, I can find the mechanical advantage by taking the force out divided by the force in. So my force out is 88.98 newtons. My force in is 44.49 newtons. So if I calculate that, 88.98 newtons normally divided by 44.49 newtons with the help of the simple machine gives me a mechanical advantage of 2. 2. In other words, the incline makes the effort twice as easy. It requires half the force, double the distance, so it's twice as easy on me in terms of force. Okay, now it might take longer. I might have to go for a longer distance, but at least I don't have to put in as much force to get the job done. And I get the same job done either way. The work is the same. Let's look at another example. Okay, so now we got a crowbar prying open the lid of a crate. So you've got kind of like a claw on one end of this, and it's basically just a lever. So you jam the claw end in between the lid of the crate and the rest of the body of the crate. You push down on one side to try and lift the other. The mechanical advantage of this crowbar is 50. So let's try and figure out which one of these makes the most sense. Okay, it would be 50 times harder to open the lid without the crowbar. Well, let's think about that. If our mechanical advantage is 50, that should mean using the crowbar makes it 50 times easier than normal. So if we're not using the crowbar, it would be 50 times harder compared to using the crowbar. So if I don't use the crowbar, that's going to be 50 times harder than using the crowbar. So I mean, that looks like a pretty good choice. So let's select that there. Let's look at the other ones though, just to make sure. It would be 50 times easier to open the lid without the crowbar. Okay, well, that would not make sense if our mechanical advantage is this big. Okay, the bigger mechanical advantage is, the easier it is with the simple machine. So this is kind of a tricky wording thing. Okay, it would be 50 times easier to use the crowbar. Okay, but not without the crowbar. Okay, so this one's kind of backwards. Normally we talk about it in the other direction. The crowbar must move 50 centimeters. I mean, nothing says that it has to. All this 50 means is that whether you are applying 10 newtons of force or 100 newtons of force or whatever normally, this is going to be 50 times easier when you do use the crowbar. Same goes for this one here. It doesn't necessarily mean it has to take 50 newtons of force. It could take 100. It could be 5. But this is saying that's going to be 50 times easier if I use the crowbar. And therefore, if I don't have the crowbar, it's going to be 50 times harder. Let's look at another example. A baseball bat has a mechanical advantage of 0.1. Which one's true? Okay, well, if I'm getting a number like 0.1, that's less than 1. That means that whatever force in I have down here using the simple machine, that's going to be like way bigger than the force out that I would normally have to do to do this task. So that would mean that using the baseball bat means it's going to take more force. So these two options look pretty good. Okay. The question is, will it be done faster or slower? Okay. Well, if I have to put in more force to get a job done, and it also takes more time for me to do it, that kind of defeats the point. At that point, it's just like a bad situation. Okay. I wanted to be able to trade that off. If I put in the extra effort and put in more force, I want the job done quicker. I want it done faster. Okay. Otherwise, maybe I'll have a simple machine that requires less work, but it does the job slower. Okay. So these two options are not really options we'll see a lot with simple machines, unless they're doing their job very poorly or they're not working as intended or something like that. But with a mechanical advantage that's less than 1, that means that we end up putting in more force to get the job done faster. We end up having to move less distance on our part to get the same work done. Okay, on page 5, we want to calculate the mechanical advantage of this ramp. Okay, it takes 1,400 newtons of force for a person to travel up a 2-meter ladder. Okay, so if they're just going straight upwards, it takes 1,400 newtons of force. Okay, if you use a wheelchair ramp to reach the same elevation, you end up having to travel a farther distance. You end up going 40 meters instead of 2 meters. But it only takes 70 newtons of force to roll up the ramp. So what is the mechanical advantage of our ramp in this case? Well, let's calculate it. Okay, our force out is going to be how much it normally takes to reach that elevation to go up 2 meters. Okay, and that is 1,400 newtons. Okay, if I divide it by how much force it takes using the simple machine, the force in, which was 70 newtons, I get a mechanical advantage of 20. What that means is it's 20 times easier, and I have to use 20 times less force if I'm using the simple machine. Without it, it would be 20 times harder. You can also see this in the distance. My distance I have to cover without the simple machine is now 20 times farther. If I take 2 times 20, I get 40 meters. Okay, I have to travel 20 times the distance going back and forth up the ramp, but at least I only have to put in 20 times less force to get the same job done. Okay, let's go do this last one. Okay, the mechanical advantage given by a simple machine can be calculated with the following equation. Okay, so same equation. In this case, we want to try and rank some simple machines from the highest to the lowest mechanical advantage. Okay, so this says we've got 3 situations here, and I want to put the highest mechanical advantage on top, the lowest on the bottom. In each case, the mechanical advantage is going to be the normal amount of force divided by the force I have to put in using the simple machine. So on this first one, it takes 5 newtons to lift a bucket in a well if I just pull it up by hand. But if I use a wheel and axle to kind of crank it and reel it up, it only takes 1 newton for me. So if I take 5 newtons, 5 divided by 1, so 5 newtons normally, 1 newton using the wheel and axle to crank it up, I get an answer of 5. Okay, so my mechanical advantage here is 5. Now that is good. It means that I have to put in less force for sure. And it's 5 times easier for me, but I got to see how it compares to these other situations. So let's keep that in mind. Let me put this in my notepad. So I'm going to say for bucket, I took mechanical advantage of 5. Okay. Let's see what this does. Oh, that makes it full screen. I don't need the full screen. Okay, let's minimize it. Okay. So let's check out this one. It takes 400 newtons to lift a sofa into a moving van, but if we use an inclined plane or a ramp, it takes 100 newtons instead. So let's calculate that. Normally it takes 400 newtons. Using the ramp, the incline, it takes 100 newtons. So I'm going to take 400 divided by the 100 it takes with the simple machine, and I get 4. Okay, so I'm moving a bigger object, but it doesn't necessarily mean my mechanical advantage is going to be better than other situations. Sofa has a mechanical advantage of 4 for that ramp. So it's less about the ultimate force you put in or out. It's more about how it compares with and without the simple machine. Okay, last one. It takes 4,000 newtons to lift a piano. Using a system of pulleys, it takes 500 newtons instead. So let's calculate this. I'm going to take the usual 4,000 newtons divided by 500 that it takes using the system of pulleys. What I get is 8. To lift my piano, it becomes 8 times easier using that system of pulleys. Okay, so let's use this to answer my questions here. So it takes 5 newtons. So I want the highest mechanical advantage on the top, the biggest one, which in this case is this guy. Okay, it becomes 8 times easier using this system of pulleys to lift this piano. And it becomes 5 times easier using the wheel and axle here. It becomes 4 times easier using my inclined plane. So this is my highest mechanical advantage. It makes the job easiest compared to how it would normally be. This is my lowest mechanical advantage. Doesn't necessarily mean it makes it harder on me, but out of these situations, this doesn't make it as easy as these other simple machines do, comparing the force you'd normally use to the force that you're using in this case. Okay, and that's the assignment. So mechanical advantage is a great way to be able to just look at a situation at a glance and see how your simple machine is helping you do the same work.